Hello guys, welcome back to my new stream. We are working on smoking drinking classification dataset. So this is a classification problem. So we have done data cleaning, EDA part, and also feature restriction part, feature scaling also we have done. We have we have trained our model using multiple different models. We are getting around 73% accuracy using logistic regression model, and we are getting around similar 73% accuracy using random forest classifier, and we are getting 74% accuracy using gradient boosting algorithm. After that, we have done some visualization. So today, what we will do, we will find which will be our best fitting model for our data set, and then also we will continue with our visualization. What else we can you can say plot using our data. So if you know, in previous stream we are creating visualization using ChatGPT. So let me open that chat of ChatGPT. So currently I am running a program in which I am getting the best fitted model, also using hyperparametric tuning, which hyperparameter give me maximum accuracy with which algorithm. This is running around 73 minutes. So let's continue with the visualization. So we have plotted scatter plot with the BMI and waistline. Now, हेलो
चलो हाँ विकास।
हाँ चाचा जी।
अरे जो नहर नहीं है अपने यहाँ पर तो नहर
हाँ
पूरे एक तो आधा किलो तो डोलू लिया तो बकरी दो लाऊंगा मैं। अरे स्टील गिलास लिया, स्टील गिलास में अंदाजा लगता है ना पहिया हुआ स्टील गिलास में वो लिया। ठीक है कोई बात को नहीं अंकल। एक तो स्टील गिलास लिया और आधा किलो दूध का तो बोतल लिया, डोलू लिया।
एक बार मैं तो काम कर रहा था, शुभम को भेज दूं क्या?
और बाइक पे कैसे आओगा वो?
फिर
फिर मेरा तो दूध देंगे ना बकरी का।
ठीक
बड़े
है
मुझे दूध पाना रहे हो।
ठीक है
उसने
ठीक है, आता हूँ। कहाँ पे? नहर पे। कहाँ पे?
नहर पे आओ ना, नहर पे। हाँ
हाँ
नहर जयंती देवी मंदिर रोड पे
हाँ
में आजा स्टील का गिलास और डोलू आजा।
Sorry guys, I got stuck in some work. So let's continue. So now we are heading towards our visualization. So we have created scatter plot of height versus weight and waistline versus BMI. Now we are creating box plot of blood pressure distribution. We have to use box plot to show the distribution of SBP and DBP. Let's see how can we use it. For that, what we have to do, we have to SNS dot box plot. In box plot, we have to dot SDF and SBP DBP. Let me see what's my column name. So I have capital SBP and capital DBP. For X, I have SBP, and for Y, I have capital DBP. Okay, and now what other parameters we have for box plot? Let me check. We have full. Okay, the palette. So let me now add title. Our title will be box plot of blood pressure distribution. We can create a dot show. This command will take time to run because currently this command is running, so that's why we have to wait. Till then, we will work on our next command. That is, we have to create line procedure to see hemoglobin levels, or you can say hemoglobin trends. Level A to observe trend or pattern. Okay. SNS dot line plot for what we have to create. Our data will be. Let me check the parameters. So for first parameter is data, that is DF. Second is X. X will be our hemoglobin, I guess. Yes, it will be hemoglobin. Let me check what's the column name of hemoglobin. So here you can see it is small hemoglobin. So in X we can use hemoglobin. For Y we have to give our age. Let me check how is our age column. So our age column works this way. Age. Let me give title to this. hemoglobin. Oh, I have to give this in string format. Hemoglobin over age. Oh, I have to use plenty.show. Plenty.show. I think this will take a lot more time. So we can do one thing. We can stop this and then we can run this. And another line plot what we can do, cholesterol levels, total HDL, LDL, triglyceride, steroid, trends plot, completion. So let me SMS plot, line plot, data will be DF, X will be our first it will be HDF, HDL, let me see. It is capital or small. Here you can see it is HDL coal. And we have to plot this over age, I guess. Yes, over age, comma, y is equal to age. Again, we have to do the same thing for total cholesterol, LDL cholesterol, and triglyceride cholesterol. We can also change every color line, uh, uh, every line with different color. Like for you can say for total cholesterol we can use blue. For uh, L LDL we can use yellow. For HDL we can use red. This way. Let me now do one thing. Let's see if there any column palette. We will use this hyperparameter for changing our color scheme. For now, let me rub this and remove this and just float in a simple way. Let me check what is the meaning of triglyceride. Are a type of fat there. Okay, so it is a type of fat. Relation of hydrogen. Okay. So the correlation heat map showing the correlation between different health parameters like blood pressure, cholesterol levels, and its other relationship with relationship and potential dependency. I think we already have created a correlation heat map. Let me see. Here you can see we have already created this correlation heat map. You can here see sex is negatively correlated with hemoglobin. It is around 70%, or you can say minus 0.7. Also, height is also negatively correlated with, you can say, sex. Here, uh, here you can see sex is negatively correlated with height. Okay. It is also correlated with weight. It is also, you can say, negatively correlated with SMK, set type 30. Here, height and weight are positively correlated. Here we can see. Similarly here, so we have our correlation matrix, or you can say correlation heat map. And this is done. Till then, let's create our next visualization. Now it's turn to create some pie charts. So we have to create smoking status distribution. What we can do, we can create a pie chart to show the distribution of smoking. Okay. So our column name is this. Let me cross check it and see what are the unique values inside this. So we have 1, 3. Okay, there are all numeric values. So let me do one thing. df of s m k stat type ct dot value counts. This will provide the value count of unique values, and for finding pi I will create for creating pi chart I will use sns dot pi. Oh, so pi chart is in prt, that is matplotlib dot py plot. plt.py, and our x will be our this value, and our label will be, you can say, similar like same like, just we have to add dot index, then explore other hyperparameters. I think we also have to use auto pct to see auto pct in py. We have used, we will use percent dot one. So we need just, you can say, one decimal point after decimal. We need just one digit. So plt dot title, here what you can do, you can write this as smoking distribution, and after that we can use plt dot show. Okay. So next we have to, what we have to do, we have to use blood type. We have to create blood type distribution. If available, plot a pie plot showing the distribution of blood types. Let's see. Let me check the columns. Is there any blood type? Here we have blood type PLDS. So what we can do, this all have numeric values. We cannot create pie chart using this. So now what I am doing, I am stopping my training process because this is taking lots of time. I will show you tomorrow what are these results. So till now, let me stop this kernel, interrupt my kernel, and stop this process. Okay, yes, I want to restart my kernel. So now I have to run my complete notebook again. Also, what we can do, we can draw our, we can start drawing our visualization here. So till then, let me again run my complete notebook. So from now, from here I have to start my visualization part. What we can do, we can cut this cell and paste it here. Now it is title. It is a distribution. Here you can see. Just a second, let me check. Am I live or not? Here you can see. Just a second. After a distribution, what we have, then after we have gender distribution. Let me cut this cell and again paste it here. Or we can say sex distribution. After that, we have created scatter plot with a height and weight. Let me again cut this cell and paste it above. Paste it here. Scatter plot between height and weight. Then let me plot this scatter plot here. This is scatter plot between BMI and waistline. Scatter plot between BMI and waistline. Now we are creating box plot. Box plot of blood pressure distribution. How we are getting some undesirable results. Okay. Let me check what's inside. DF of SBP dot unique it is not. You might get covered with so many unequal loads. I think we have to create, instead of box plot, we can use a scatter plot here. Let me use scatter plot here. Scatter plot. Our columns will be same. Scatter plot. Here we can see a nice graph. Let me do one thing. Let's head towards our next visualization. Let me cut this side and paste it here. Now take is a line plot of the globing over age. So let's try to run this. Till then, we can cut our next visualization. So this line plot between our cholesterol levels. As you can see, we get our nice visualization. Now, similarly, let me visualize it for our cholesterol levels. Line plot of cholesterol levels over age, and here let me use palette in seaborn. Let me use this graph, or you can see use this command. Let me do one thing. List of color palettes and save. Let me do one thing. Let me give as it is red, blue. Here inside palette, let me write red. After that, for let me write yellow. and then for palette, let me write green, and for tranquilize red, let me write blue. Let's see what we get. We get our result or not. Okay, then let me copy paste my next visualization. And let me cut my cell and paste it here. Here, paste it. So this is pie plot, pie chart of smoking status distribution. What we can do, so inside label we have give the index, but index is like 1 2 3. So let me select my data set here. Inside this smoking column we have three sets. One is never, one is used to smoke but quit, and 3 stand for stealth smoke. We can copy this and try to give this as our label name. Let's see. First, let me check the unique value counts. Till then, what we can do, we can move to our next visualization for blood type distribution. Okay, similarly, it is of you can say a numeric value. We have to create this into a bin. Instead of pie chart, we can also create. So here we get our visualization. This visualization, we can see this is not so pretty. I guess we have to create all different use all different visualization. We cannot use this in a single visualization. Then plot of HDL cholesterol level. Here instead of HDL we have to use LDL. Then here instead of LDL we have to use total cholesterol. Then here but we have okay, our palette is red, but I am getting this is blue. triglyceride orange. So this is already copied here. Also, I'm getting this in. You can say I wrote here palette as yellow, but getting in blue. What we can do? Let me use a palette set to. Let's see what I get for set 2. What will I get? Instead of giving these labels, I can use never used to smoke but quit. And our third label will be still smoke. Let me try this. Here you can see we are getting nice results. We can delete this distribution, delete this also, this one also. Let's check for set 2. Still I'm getting this in blue color. What's the reason? Not getting the problem. Why I'm getting this all in blue color? Okay, let's repeat it and remove this pattern. We can do one more thing also. We can create these 4 plots in subplots. For that I have to use fig comma x is equal to figure on I have to use to dot figure and I want to plot 1, 2, 3, 4, 2, 2 plot with figure size. My figure size will be, you can say, 6, 6. And here I have to give the axis x is equal to x, a, 0, or I have to give 0.1. Let me check this. Here I can check this. Create subplots in C. So we have to use plt.subplots. Then we have to give fixed size. Okay. plt.subplots. Subplots. Let's try this. For creating subplots, we have to use. Okay. I guess I have to use 2 because my dimension is 2 plus 2. Set title. Yes. No. Let's try to run this command. How this will execute. Okay, you can see we are getting our results. Let me increase the image size, and here we are getting a nice, you can see, nice visualization. Instead of 6, let me go 12. And here let me also give set x label of, you can see, x-axis. I guess we have x-axis or in our x-axis we have HDL cholesterol and set while X is as age. Or there is set X label. So we do not have X axis. We let me try for X label also. No, 5 labels. Let me check what I used in my previous project. I guess I used this in this project or not. Here we get our results. Yes, we are clearly getting our results. Now let me copy this for. Now instead of HDL, we have to use LDL, and after that we have to use total cholesterol. Total cholesterol is TOT. Okay. For triglyceride, now we head towards our next visualization, and that is hearing and sight impaired, impairment by sex. Show the count of percentage of individuals with impaired hearing or sight for each sex. We can use whole for sex and the number. So we have created a new data frame, that is a new column, sorry, total impairment when it left here, right here plus, let me copy this code and paste it here. So we have all these predefined. Calculate the count of impaired hearing and sight space x. So for that, we sum all these columns. Okay, let me check what's inside this column. So we have float values here. Okay. So then we use group by sex on total implement column. Then what we do, we calculated the percentage for percentage. Here we group divided by total percentage of sex. And then calculated percentage. Oh, so I created a blunder here. I have to use 0, 1 here, 0, 1, 0, 1, 0, 1, and here 1, 0, 1, 0, 1, 0, and 1, 0. And after that I have to use 1, 1. Here also I have to use 1, 1, 1, 1. And it will take for the time. That's it. And after that we will work on this. Then our next thing is to urine protein prevalence by. So I will do similar thing with this. Copy this code and paste it here. So what's this iterability? And this is urine file implement by 6. Now we can use stacked area plot in between cholesterol components over age. Again, we will take use of Python for this. Write Python code for stacked area plot. And then we will edit this code and take, let's see, my site is still running. Now we are creating code for while and float. Let's use ChatGPT while create Python code for while and float. Here a site distribution use while and float to visualize the distribution of site left and right to understand any variation or outliers. This title will be distribution of while while float of let me check. So we get this distribution here. So now we have to work on this hearing and sight impairment by sex. Let's work on this. So first, I just calculated this. Let me check. We get a single column sum of all these values. Okay. So after this, it grouped by this complete column, this column with sex. Let me check. If we group by this with sex, group by sex, this let we will group by using here left. What we get dot sum. We will get a value counts. Okay, and if I will group by the complete sex column and then use size, I think I will get the okay. I will get for the number, or you can say value counts. Can I do this with same using value counts? Let me check for sex dot value counts. You can see I can do dot value counts here instead of this group by thing. Okay, and also okay. And then give the let's run this count. Let me remove this. We can say instead of this we can then first we are creating x dot bar less defining label. Let's see what we get. So we are getting total impairment, but we are not getting percentage impairment. We have TF of float. We have index. So we have our values and 4p in index. Let me check what's inside index. Index we have two values 0 and we have range between 0 to 2. Okay. Let me do one thing. Let me comment this first code. Now we are getting value 4 percentage here around 400. This is less than 400. Now this is around 2000. Okay. So what we can do, we can create subplots and there we can use this plt dot subplots with 1, 2, load sizes, or you can say fig size. Figure size. Fig sizes 12,6 and this will plot for 0, 0 points 0, 1 and let this will plot for sorry 0, 1 and this for 0, 0. Here I have index. Okay. We use if we paste this here and see 0, 0. And I'm sorry, today I have very less energy, and from tomorrow I will try my best to come back in high energy. Here we have percentage and there we have pound. See, comma, comma 1. And this is also for let's try to Actually, I have to do this in confirmation. Okay, so we already have this command. We have to just cut and paste it here. Let's say, and here it doesn't have set title attribute, but here you can see we are getting correct visualization. Now we will change. Now we can use PLT dot title. Let's see this now. This will given just single graph. I have to write this in both visualization. For that I have to use again set title with ax of 1. I have to copy this thing and write it here and again give this to here. Here I can remove this legend part and instead of title I can use this percentage compare but here instead of total improvement. Now let me remove this label here also let me remove this label. Now let me try doing this. Here we get a beautiful visualization. We want this visualization. Here it is our sets and here it is our count. Nice. Now we head towards our urine protein presence by age group. So we have this. I think today I'm not feeling so well. So we will continue this for tomorrow. And tomorrow also I will calculate this, which will be the best algorithm for our dataset using this code, and I will explain you tomorrow how we can use this code, how I use this code for finding best parameter, or you can say best algorithm with best parameter. So for today, I guess this is enough. Thanks for watching and have a nice day.